So this lecture is just a relatively brief introduction into text mining. Um, Text mining is actually a really pretty broad field, um, and it can be used synonymously with text analytics. So, one little lecture about it is by no means all-encompassing. And it's going to include a range of technologies for analyzing, processing semi-structured and unstructured data, basically taking your text and turning it into numbers. It intersects with six other major fields, including data mining, artificial intelligence and machine learning, computational linguistics, library and information sciences, databases, and statistics. We have seven distinct practice areas that text mining consists of. So that would be document classification, document clustering, information retrieval, web mining, concept extraction, natural language processing, and information extraction. So we can kind of see how all these different things overlap and interact together in this diagram here. So how does text mining work? So we take our text packages, we'll call them documents, and they're collected into a database called a corpus. The corpus then gets pre-processed for cleaning by removing high frequency, low information words like conjugates such as and, or, but, and then we strip the words down to their roots by removing their tenses. Now we can look at the words as terms. Then we build a matrix where we count the occurrence of terms in each document. And then we run the black box, which does something to discover the discussion's topics. And it gives lists of terms and documents for each of our topics. So this black box has two main classes that you can look at. So there's two different ways that you can do it. You can either have a context word model where you have a word by word co-occurrence where you count the frequencies word by word. We don't really have any known business applications of this, but it is very useful in cognitive science. And then we could also have context regions models based on a word by document occurrence, where it counts the frequency of each word in the document. And this tends to be pretty dominant in business modeling as well as research. So remember when you're running your black box, so you can either have it be text topic based or you can have it be frequency based. Text mining is a developing field that involves a lot of new approaches to include things like identifying the sentiment of a text, called sentiment analysis. In general, text mining would be referred to analyzing non-numeric data with the idea of extracting knowledge from the text that's posted electronically. One simple way to approach such of an analysis is to create a library of synonyms and then match things, but text mining is capable of doing some very interesting things, such as identifying key terms, understanding context, and using that to identify our relationships. It's been used by a variety of firms. Dow Chemical first began using text mining for themselves in 1996. They access hundreds of thousands of documents obtained over the internet and other sources in efforts to identify potentially new customers, new business partners, and market trends. The point is that there are a lot of valuable things that business organizations can use text mining for. The idea of text mining is to identify key terms and then use that as a semantic dictionary of synonyms that can be built with experience. This can be done manually and inserted into the system, or you can use machine learning. Machine learning is capable of identifying multiple forms of root words and phrases from multiple words and generating synonyms through experience. Obviously, manually, people are also capable of doing these things, but machines aren't naturally capable of doing this. So it has taken some effort to develop the ability to act like a human in text mining. So here we have an example of complaints that people have posted about a printer. The first complaint concerned an inkjet printer and it dealt with Ben as the customer service representative. The comment was that this printer is a piece of junk. It is so cheap that it constantly clogs. In futile attempts to fix it, it breaks regularly. So in bold, you can see the terms that provide some clue as to the sentiment of the commenter, which is obviously unhappy in this case. We would easily realize that this is a negative comment, and we would look for words like junk, cheap, clogs, and brakes. Now, in the second comment we have that Abner took was, I wish to commend your representative who was very understanding of my lack of knowledge and kindly provided help. So this is a positive comment, and the sentiment is the complete opposite of the first one. But some of the typical words that you would hope to see or expect to see in such a positive comment include understanding, knowledge, and kindly. The catch is that we rarely see comments quite as blatantly obvious as this. We tend to kind of hide our sentiments by mixing up our context, and computers kind of have a rough time dealing with that. Um, and so, if things are straightforward, the computer does great. Like we saw in the first two comments, computers do a really good job identifying the intended sentiment of the comment. I will say, if they aren't that straightforward, you really can confuse the computer pretty easily. So if you enter this into a software system, in this case it's the PolyAnalyst software, link analysis will provide a useful graphical tool to see the degree to which the words go together in the comments. So the links come in a variety of forms. We have the words on the left and we have the people on the right. We have the types of printers on the lower right. The representative Abner, for instance, has been associated with 3 comments. And it appears that Abner's comments ranged from the first one that we saw earlier that was very positive to another one that was talked about abusive and smear, which probably was negative. And another that involved paper and cost, which is, kind of hard to classify directly. So you can kind of see the links between the laser printer and the representatives that have dealt with these comments. It was Chicken Dennis in this case, and the types of comments that you see, you can kind of gain some kind of pattern recognition for these kinds of performance that laser printers offer, for instance. So in this case, we see that laser printers are associated with purchase, cheap, and cost. You would need more information to draw conclusions off of that, but the link analysis is demonstrated by this display. It can kind of just show you the relative degree of time so that terms coexist. When you're using this software, you can set the minimum limit. In this case, it's just set to 0. If you slide the minimum limit to the right, some of these lines disappear and the intensity of the bold lines would diminish. And you can slide to the other end and adjust the maximum. You can click on any line to see specific comments. 3 of the specific comments are shown below in the bottom window. And so here with this project, it successfully created from the file was the first of those was comment number 8.56.18, which was listed there to show that you can tie each link to the comments behind it. So the idea of using association rules is very helpful. Ichabik and his colleagues talked about discovering rules from legal databases. So they obtained an electronic form of legal databases and they applied the data mining technique of association rules, which automatically identify the kinds of things that go together set by various levels of support and other parameters that you can set on a computer algorithm. Association rules in this case generated many, many, many rules, and the problem was filtering these down into interesting rules. The term interesting applies here, refers to data mining applications where you obtain some information that is relatively strong and unexpected. Of course, unexpected is a human concept and computers don't know that one. So usually you need to interpret the computer output with human interpretation. A brute force kind of algorithm would count the number of times events occurred together. And in this database, for instance, there were over 30,000 assault cases in Texas the year prior to the study. Of those 30,000, almost 10,000 of those were assaults by relatives. And so you can identify the proportion obviously by dividing the total number of events by relatives by the total number of the base events, which would be 9,843 divided by 30,052, which gives you a ratio of 0.316. And that would tell you the degree of the strength of that specific rule, which would say if you were in an assault case in Texas, you ought to look for relatives with a confidence degree of 0.316. And the support is the 9,843 cases that you used. So in another legal application, there were over 380,000 applications for legal aid. Web access allowed users to express level of confidence gained from the rules that were generated by the computer algorithm. The system included over 300 variables, and 7 of those variables were selected as the most important and interesting within the context of what we talked about earlier. Over 226,000 possible association rules were then generated. So just looking at the pairs of one antecedent and one consequence. All expected relationships were identified by expert opinion, and the support identified with correlation with the actual data. So if confidence and support differed by less than a parameter setting of 0.1, it was considered not interesting. So this shows a way in which interesting can be measured in the context of association rules. The method was tested on 3 experts with 144 rules. Surprising associations led to new posed relationships with the experts, and they were asked why they thought that might be true. And so if there was reasonable rationale that an expert identified, then the rule was retained. Otherwise, it was thrown away as a frivolous rule. So, that's just one example of where text mining can be applied. You can also use text mining to filter and match resumes to open positions. You can identify documents of interest to forward to specific users. You can also use it for help desks to monitor quality control. It also gives you the ability to monitor massive volumes of text as Dow did to obtain competitive intelligence, or as insurance companies might do to help detect fraud. A second very broad category of application is in web mining, because the internet is packed with documents. Web mining can be used to search these documents and again, to monitor customer behavior in e-business applications, and to interactively modify customer behavior through clickstream analysis and other techniques. Web mining has been used for things like information retrieval to select information and extract what you want and pre-process, as well as generalize and lead to more intelligent kinds of conclusions and knowledge discovery. There is a taxonomy of web mining. Web content mining is browsing the web to discover useful information. It might be used, for instance, to identify what given profile of customer we might be interested in. Web structure mining is focused on how web pages are linked together, and you are interested in link analysis to determine the number of times that different websites might interact, for instance. Web usage mining has to do with how users behave on a given web page. And so this is where that clickstream analysis would come into play, which is following the cursor icon movements over the web page and analyzing the data from server logs. And that can all be used to gain new knowledge. In e-business with clickstream analysis, sometimes personalization is applied, which tailors sites for specific users. Amazon is a prime example of that, where my web is going to be tailored to come up with a recommended book or other products, maybe music that I've bought in the past. And so Amazon has algorithms available to recommend products that I might be interested in buying. And these are tools available to help Amazon and other web personalization appliers operate, such as agents, which are computer programs specifically programmed for little tasks for the site, and bots, which are automatic behavior agents of a type. So there are many examples of web mining. Three specific ones from the past include United Sugars Corporation, who utilized web mining for supply chain optimization, obtaining information from an ERP, developing a decision support system to take the information that it obtained from the ERP and running it through an optimization algorithm, and then recommending decisions to improve the performance of the supply chain. Web access also is used to monitor product quality. So we have Cameron and Barkley used web mining to reduce inventory while trying to assure having sufficient inventory while having to maintain service levels, and web interface captured user interactions. Lockheed Martin's astronautics division used web mining to monitor their production system and published reports on the performance of their operations on the web. So once again, web mining can be very useful in a wide variety of applications. We can use weblog data, clickstream analysis, and you can mine weblog summaries. And we've got another tool that's sometimes used to optimize such systems in data mining is called a support vector machine. So support vector machines find hyperplanes, which are the best line in 2 dimensions, or triangle or surface area in 3 dimensions, that separate data into categories with a maximum degree of difference measured by some function. So support vector machines can then separate the data into clusters, and it follows a risk minimization principle, which is to find the hypothesis with the lowest probability of error that the overtraining of the sample occurred. Overtraining is when the data is overfit, and it has a very low training error, but it ends up being pretty unreliable and typically doesn't work well when I bring in an outside data set. Support vector machines are a form of knowledge engineering. Typically, experts manually generate rules, so you can also apply support vector machines through supervised machine learning. And that's just one tool. There are a variety of other tools that enable you to deal with text data as well. Naive Bayes models assume word independence. That's the naive part. K-nearest neighbor, a clustering technique. Decision trees are a classification technique that we've seen. Logistic regression and neural networks are 2 others that are used with classification models. You might also be able to boost the fit of the models in data mining through least absolute value regression, or support vector machines using Euclidean metrics. Support vector machine applications of text mining include automatic assignment of semantic categories to natural language text. For example, Yahoo is able to classify web pages by topic, and e-business sites are able to customize their sites to user preferences. Help desks could assign new cases to their best expert. So in summary, web mining has grown very rapidly, and it's a source of taking qualitative text input and converting it into quantitative data. And it can be used to monitor web behavior and as a source of data for text mining. Text mining is a much more challenging kind of application.